Enrico, thank you for joining us today. And we'd like to talk about the scale up on the pilot plant and ultimately the industrial facility. But before we get into that, can you just give us a little bit of background as to why you got involved with Argex in the first place and what sort of potential that you see with the company?
Okay. I've been surrounded by the TiO2 industry my whole career, even though I was in steel. I started out at Atlas Stainless Steel, and I had QIT across the street, lots of friends there. At the time in the 90s, the largest polluter of the St. Lawrence Seaway was dioxide, and that was to my left. And so I was always surrounded by TiO2, and it was an accidental meeting that I met Argex. I would listen to their project with respect to environmental permitting, and basically I pointed out that I thought what advantages they had. I introduced them to Investissement Quebec and others in Quebec, and at that point I had already become a shareholder because I believed in the potential, and I eventually decided to join in the beginning of May 2011. And at that time, I would say that I don't feel like everything was in place, but I felt the potential was enormous. Today, I can say that all the pieces are in place, and I feel very strongly about it. And I think it'll be a game changer.
Well, it's interesting that you became a shareholder before you officially joined the company, and that dovetails into your last comment about it becoming a game changer. Maybe just in summary, if you can define game changer just a bit.
So, right now, rutile, natural rutile, has become rarer and rarer, and the prices have gone up. Prices range from $2,000 to $3,000 a ton currently, and the prices range between sulfate process or chloride process. Chloride process being the higher cost portion of that curve. In this particular case, if you're looking at that range of prices and I'm only paying $150 to $200 a ton, it stands to reason I have a significant raw material cost advantage. That said, also every single byproduct is a saleable pure product, which is different than the other processes, so that we also have a better environmental footprint.
In short, then, other reserves that may not be economic for some other company suddenly become economic for Argex, is what you're saying.
Absolutely. In fact, we're the only ones looking at a specific crystalline form. In most cases, the raw material for the other processes is basically a spec sheet that you have to meet, be it for things that affect the color, or be it elements that would melt at lower temperatures than what the chloride process fluidized bed would operate at. In our case, the onus is on the solvent extraction for the purification. So we're able to make chloride quality product or better with what many people would call dirty ilmenite.
Okay, that gets towards the game changer, but let's get into the pilot plant now. Very recently, Argex announced that it had reached full scale up on the pilot plant and expected production. Just detail a bit for us what was involved in getting the pilot plant to the point that it's at now.
Yeah, so basically what it entailed was basically redoing the mass balance to that size for 10 kilograms per day, and then outsourcing the construction of these mixer settlers and these leach tanks that were larger. And then from there is the fabrication of that and then putting them in place. I know it sounds very simple, but that's really all it is. It's a carbon copy of the smaller ones, just a little bigger.
Okay, and there was about a 60-day delay from when the announcement went out about being fully operational compared to the expectation that the plant would be at 100% in early July, which caused some angst amongst investors for a short period of time. But what was behind that delay? Was it an equipment issue or what?
Yeah, actually, it was a delivery issue, and you're correct. In a way, it is an equipment issue. These types of pilot plants are one-offs. It's not like your major equipment vendors in this industry, be it Outokumpu, FL Smith. You got Tenova, which was the former Bateman. You got the Krebs, which is Technip today. These are all major vendors, and when you make project timelines, they're offering you things that they've designed and done many times, and they know what their timelines for engineering, fabrication, and delivery are. These one-offs, this is a different style or level of fabrication, which is not what you call your industrial scale. And what happened in this particular case, rare earths became quite in vogue, and everybody's building pilot plants doing solvent extraction. So this pilot plant fabricator had quite a few orders at the same time, and the orders were delayed.
Okay, so in no way, shape, or form then was there any concern about the process? This really was what I'll call a mechanical issue.
Exactly. It was just a fabrication issue from basically a one-off type fabricator of these mixer settlers.
Okay. So with what you've learned in the past and with the scale-up of the pilot plant, is it performing now as expected? And then dovetailing that into ultimately an industrial facility, are you as comfortable now as you have been in the past, or more comfortable that you've alleviated any concerns about process and in fact can impart that message to investors?
Absolutely, and it's performing exactly as expected. Solvent extraction typically scales from 15,000 to 100,000 times. If you look at the large electrowinning plants like in Vossey's Bay, which was the old Inco or Vale plant, the scale up of that was substantially larger than what we're going to try to do. Electrowinning plants require a much larger solvent extraction front end to match to the electrowinning to justify it. Copper is the same type of challenge. Then you've got a number of plants out there like the uraniums out in northern Saskatchewan. I had the opportunity to visit two of them, and very similar to what we would be doing. In fact, one of them was built in the 1970s, and interestingly enough, the layout and the equipment was going to be very similar to what we'll still put in today in 2012.
So in other words, the equipment is not the key to this, it's the process you've developed and then how you utilize that equipment. Is that what you're saying?
Yeah, basically, exactly. Solvent extraction is just a mixer and a settler, right? So if you visualize it, it's an organic that picks up one element. So in our case, we have one for iron, one for titanium, and we only have really three byproducts. In our case, it's relative. If it works, it'll work, and then it's just a matter of how much time does it take after you've mixed it to properly separate, and then you're siphoning off the organic at the top for the organics, and then you're siphoning off the solution at the bottom. And so once you've removed the iron, that solution goes on to the next circuit to remove the titanium, and it's always a closed loop circuit. So you load it with titanium in the organic, you unload it, the organic goes back, gets loaded again, and goes back in circles in a closed loop. And it's the same with the iron circuit. These are things that have been done a long time. If you talk to any of the major vendors in this industry, they'll all tell you that it's if the metallurgy works and you know all of the separation times and you test them and you evaluate them, then they can replicate it at a larger scale.
Enrico, thank you for your comments, and we all certainly look forward to the day that Argex becomes a game changer. Thank you.
Thank you.